Welcome to parametric curves and tangent slope. So the general idea here is while a parametric curve is defined by the two equations, both in terms of t, ultimately, the curve itself is just a curve in the xy plane. As a result, we can talk about tangent lines and tangent slope. So we can talk about tangent lines and tangent slope. And tangent slope should still be dy dx, how y changes in relation to x. So the question becomes essentially, how do we find dy dx when we have two separate equations, both in terms of t? So suppose we have the parametric equations. X equals f of t and y equals g of t. Okay. To find dy dx, what we want to do is we use a chain rule. So note, from both of these equations, so from these equations, we can find dx dt and dy dt. Right, so we have dx dt would be f prime of t, and dy dt should be g prime of t. But we also have the chain rule as a way of finding dy dt. So, but we also have the chain rule as a way of finding dy dt. So the chain rule would say that dy dt should be equal to dy dx times dx dt. So if we solve for dy dt, dy dx, this means that dy dx should simply be equal to dy dt over dx dt, otherwise known as g prime of t over f prime of t. And so this is our rule for finding dy dx for a parametric equation. So for example, let's consider the parametric equations x of t equals t squared and y of t equals sine of t, and find dy dx in terms of t. So first we have dy dt, or we could do dx dt first. Dx dt is just the derivative with respect to t of t squared, is simply 2t. Dy dt is the derivative with respect to t of sine of t, otherwise known as cosine of t. So we therefore have dy dx is dy dt over dx dt is simply cosine of t over 2t. So this means that the tangent slope at time t is dy dx equals cosine of t over 2t. So again, this is how we can go about finding tangent slope. In the next video, we will take a look at finding the equation of tangent lines and normal lines to a parametric curve.